Welcome. Today we are going to discuss some important topics with respect to the interview points of view. Today our first problem will be painter's partition, in which we are given a set of tasks, n tasks and k workers. So in this example we have 3 workers. We need to find the minimum time to complete all the tasks. The constraints will be that one worker can take only a continuous sub-array for work. For example, first worker can take this number of tasks, but after completing this task, he cannot take another task or add to another task. He can only do continuous works. So, for example, array can be divided like this. So, K1, K2, and K3. This is how our 3 workers are doing their works. We need to see that they are doing continuous set of works in the array, and after finishing their work they cannot start another work, take work from the another workers. So we need to find the minimum time to take. These numbers depict the time to take complete one task. So these 3 units of tasks, 5 units, 1, 7, 8, etc. So the K1, the first worker will do 3, 8, 9, 16, 16 plus 8, 24. The second worker will read 7, 10, 20, 21. In 21, 4, 7, 5, 11, 16, 20, 26. So the minimum time to complete our entire task will be max of this, which will be 26. Since we need to see that 21 will not be our answer, since when K2 completes the work, K1 and K3 will still be doing their work, and hence all tasks are not complete. We need to get the minimum task when minimum time when all the tasks are complete. So the answer for this division will be 26. Now we need to minimize 26. First we need to define our search space and the minimum time and the maximum time taken, so that we can solve this problem with binary search. So first our L will be max of all elements in this array. For example, the max element here is 10, so which will be 10. Since if we had an array such that 10, 1, 1, 1 and k is equals to 2, then the minimum time will be 10. So our low will be the max of all the elements in the array, and our high will be sum of all elements in the array. Since if there is only one worker, let's say if k was 1, then he will be doing all the work. So the maximum time that can be taken is when we have only one worker, which if we have only one worker, then we need to add all the elements in the array. So the sum will be 28, 45, 65, 71. So this total sum of array is 71. Now let us keep an answer is equals to L initialize while L is less than equal to H. We need to get the minimum mid, which will be the time taken to complete, minimum time taken to complete all the tasks. So M is equals to L plus H divided by 2. Now we need to check whether all the tasks can be completed by the k number of workers in this time, in n time. So we will define another function check. We will check if this time is enough to complete all the tasks. M, I, and k number of workers. If yes, if we can complete all the tasks in this time, then our answer possible can be m, and we need to minimize this answer, so we will reduce our h to m minus 1. Else, if we cannot do all the tasks in this time, then obviously we need to increase our time, so we will increment l is m plus 1. We will be returning answer. Now I will be defining our check function here. Check m, arr, and k. Now we need to assign the first work. Now we need to check the number of workers required to do all the tasks in this time. So let's initialize count c equals to 1, since at least there will be one worker who will be doing, and some variable s equals to 0. Now for I equals to 0, I less than arr dot length I plus plus. Now we will add s plus equal to arr of I. We are checking how the time taken to do for worker 1. Now if s exceeds m, then we need to add another worker. Since m is the time that can be assigned to one worker, if exceeds m, we increment our counter c++, and for this next s will be ar of I, since the next worker will immediately starting from the point where the previous worker has stopped. Now after this for loop completes, we need to return, this is a boolean function, so return c less than equal to k. Now if the number of workers required to do the task in m time is less than k, then obviously we can complete the work. Then it is obviously true. If the number of workers required will be greater than k, then we cannot do the entire task in m time for just k workers. Now we have another problem known as aggressive cows. The problem states that we have S number of shelters, which is 5 here, and C number of cows. We need to put each cow such that they are far away from each other, and we need to find the minimum of that distance. We need to maximize the distance between each cow so that all cows can fit here. So let's say C1, our first cow is put inside the first shelter at distance at point 1, and C2 is here, C3 is here. The distance is 1, distance will be 2 here. Now the minimum of these two distances will be 1. We need to maximize this. C1, we can put C2 here and C3 here. This distance will be 7 and this distance will be 1. Another combination will be C1, C2. This distance will be 3 and C3. 4 to 5 will be 5. Now we can see minimum distance, maximum of the minimum distance between all the cows is 3. We have to return this 3. Again, mm, for for binary search, we need to define our search space and the list the low value and high value. The low will be uh, the mi- the low will be when we assigned all the curves continuously. So low will be minimum of 1 comma 2, minimum of all curves curves consecutively. So this can be done by forming C1. um, the minimum will be assigned to A1, and let's just I'll write the function here. For I is equals to 1, I is equals to 0, I less than AR of length minus 1, I plus plus, if L is less than ARR of I plus 1 minus ARR of I, L is equals to ARR of I plus 1 minus ARR of I. Initially, L will be mm, max of ARR. After this for loop, L will be the minimum distance when cows will be assigned consecutively. Now to define our H will be maximum distance will be when there will be only two cows. So the first cow will come here and the second cow will become at the end, since the array will always be sorted. If the array is not sorted, first sort the array. So the first step will be sort ARR. Now we the max minimum distance will be from AR of 0, AR of last index minus AR of 0. So H is equals to ARR of length minus 1 minus ARR of 0. This will be our maximum possible answer. Now while L less than equal to H, this problem is similar to the previous problem. M is equals to L plus H divided by 2. Now we need to check if this is a possible correct answer. We also assign answer is equals to H, initial answer is H. If check M comma ARR comma number of cows, if we can place cows at minimum distance M, then yes, this is a possible answer there. So answer equals to M, and we need to maximize this answer, so we'll increment L is equals to H M plus 1. Else if we cannot fit all the cows in this length, then we have to decrease. H is equals to M minus 1. Now again I will be writing our check function here. Check M ARR comma C. Now we have a count variable will assign to 1, since there will be one cow that will be assigned to position 1, and we need to know the last position of a cow. So since the first cow will take the first position, last position will be ARR of 0. Now we need to start for I equals to 1, I less than ARR dot length I plus plus, if M plus last. We need to check we can place the cow at this ARR for I is less than equal to AR of I. If m plus the last distance, this is the minimum distance, possible minimum distance between two curves, and the last distance is less than this current index, then which means we can place this cow here. So we will increment the number of cows, and the last position will be incremented to AR of I. Now we need to check if this is count variable or count plus plus. If count is equals to C, we can place C cows, then return true. After this false, we return false. This is the code in Java. We are maximizing distance between here. So L will be the last and H will be here. We initialize our H and L. Now let me check, correct this. Now we are going from 1 to size minus 2. So this size minus 1, and we are checking if L is minimum of I plus 1 minus and we are answer to H less than U. We are checking M. If this is possible, we try to maximize. L, we have to reduce the space. Here is a boolean check function. We are checking if this cow can fit at this position with this distance m plus l is less than a of get of I, then yes, you can fit the cows. So we increment our counter, and the last solution will be increment to a of get of I. If our counter is equal to the number of cows, then yes, we can fit this number of cows. So we turn true. Else we after the false after the fall rule loop is completed, which means we cannot fit this number of cows, then we return false. Another problem which we need to solve today is nth magical number. We need to find the nth magical number, which is the product of either A or B. Will write. I will write the products of 2 and 3, 2, 4, 6, 8, 9, 10, 12, 15. Now this is first, second, third, fourth. We need to return 8. Now just the number of products in in let's just say we have array of length in the range 1 to 10. We have 10 divided by 2 multiples of 2. 2. So for example, in the range 1 to 10, we have 10 by 2, which will be 5 multiples of 2. 1, 2, 3, 4, and this will be 5. And the number of multiple, and let's just say in 15 we have 15 by 2, which will be 7. So 1 2 3 4 5 6, wait, I forgot 14 here. 14, 15. We have 7 multiples of 2 in the range 15. Similarly, in the range 15, we have 5 multiples of 3. So, in the range 15, the multiples of 2 or 3 will be 2 or 3. Multiples of 2 or 3 will be in range 15. 2 or multiples of 2 or 3 will be 15 by 2 plus the multiples of 5, multiples of number of multiples of 2 in range 15, number of multiples of 3 in range 15, minus we need to subtract the multiples which are common. Now the common multiples are 6 and 12. Now the common multiples will be the multiples of LCM of A and B, which is LCM of 2 and 3. So multiples of LCM of 2 and 3 will be 6. Multiples of 6 in range 15 will be 2. This will be 7 plus 5 minus 2 equals to 10. So as you can see in the range type, sorry. So the multiples of 2 or 3 in this range 1 to 15 will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now to find our nth magical number, we need to initialize our L will be, if n is equals to 1, our L will be become a minimum, if first multiple of 2 or 3 will be minimum of 2 or 3. So in this case we will get 2. The first multiple of 2 or 3 will be 2, and h will be n into minimum of L a comma b. This is our a, this is our b. Since the maximum answer will be the nth multiple of the minimum of 2 or 3. Let's just say if b was 20, and a fourth multiple of 2 or 20 will be 2 into 4, which will be 8. We need to return our fourth multiple will be 6 here, so we need to return 6. 1, 2, 3, 4. While L less than equal to h, we calculate m is equals to L plus h by 2. Now we need to check how many multiples of either 2 or 3 are uh, in the range m. So C equals to m by a plus m by b divide minus m by LCM of a comma b. Now if C is equals to n, this is a possible answer. So answer will be m, and we reduce our search space to m minus 1. Else L is equals to m plus 1. Return answer. This is our nth magical number. It will return our n. Now the formula for LCM will be LCM is equals to A into B divided by GCD of A comma B. Now I'll be sharing the code. As you can see, L is minimum value of B and H will be the n will is represented by C here, so n into minimum of L comma B. Now I am finding GCD. and let me correct this, A into B divided by GCD. Now LCM will be A by A into B divided by GCD. Our answer is initialized now H, while L is less than equal to H. We calculate the medium and we calculate the number of multiples in the range M. If the range number of multiples C will be equal to N, this will be a possible answer. If any of the numbers A or B is divisible, this is the correct answer. Else we reduce our search phase, or else we increment our search phase and we return our answer. Now this is the code to find uh, GCD of A and B. I hope you have understood both the problem, all three problems we have discussed. Please try to implement this and practice in LeetCode. Thank you.